Alright, so here we have another example solving a rational equation. I'll have several of these. They'll each be a little bit different, so try to hit all the different scenarios you'll come across. Some of them, when you go to solve them, you'll end up with a linear equation to solve. Some of them you'll end up with a quadratic equation to solve. So check them out, and if you like the videos, check out all my other videos and give me a like, share, and subscribe. Alright, so whenever you're solving a rational equation, first thing you want to do is, if there's any denominators that can be factored, factor them. So we can see here the x squared minus 4, that's the difference of two squares. We can factor that. So we're going to have 1 over x minus 2 minus 1 over x plus 2 equals 4 over x minus 2 times x plus 2. Okay. Alright, so we got the denominators factored. Next, we want to state our restrictions. Alright, so what are the restrictions? Well, that's what makes the denominators 0. So it's pretty easy to figure out. So you can see in this denominator, if we plug a 2 in for x, we get 2 minus 2 is 0. That makes this fraction here undefined. Okay, so x cannot be 2. Okay, so we've got x cannot equal 2. Then we go to the next different denominator, the x plus 2. Well, if we plug a negative 2 into here, negative 2 plus 2 is 0. That would make this fraction here undefined. So x cannot equal negative 2. And then same thing here, 2 minus 2 is 0. There's your 2. Negative 2 plus 2 is 0. There's the negative 2. If you have trouble seeing it, you can always, all the different factors, set them equal to 0 and solve for x. Okay, if you need to do this. Most of the time you won't need to, but because it's just easy to plug the numbers in and see. And now sometimes you have a number here and you end up with fractions. That might come in handy, setting these equal to 0 and solving for x. Okay, and yeah, I wrote the restrictions like this. I'm sure your teacher won't mind if you write them x cannot equal plus or minus 2. Same thing. Alright, so the next thing we do is we get a common denominator. Alright, so how do we get a common denominator? Well, we look at each factor and we use the factor the most times it appears in one of the denominators. Okay, so let me show you. So here we have a factor of x minus 2 and we have a factor of x plus 2. Let's look at just one of them at a time. Okay, so let's look at the x minus 2. Well, the x minus 2 in this denominator appears one time. The x minus 2 in this denominator appears 0 times. It's not there. And the x minus 2 in this denominator appears one time. So the most number of times it appears in any denominator is once. So that means we use it one time. Then we go to the next different factor, the x plus 2. So the x plus 2 in this denominator appears 0 times. The x plus 2 in this denominator appears one time. And the x plus 2 in this denominator appears one time. So the most times it appears in any denominator is once. So we use it one time. And there is your common denominator. And what we want to do is multiply the common denominator to each term. Okay, so, and I'll write this out. I think it helps to write this out. I think it makes it easier for when you start canceling this stuff. So, I guess if your teacher tells you doesn't have to, that's fine, but I think it helps. Less likely to make a careless mistake. Alright, so now let's go through and see what cancels out. And I know this looks complicated, but look, all you did is you took this and you wrote it next to each one of those. That's all we did. Okay, so look at this. The x minus 2 and the x minus 2 cancel. The x plus 2 and the x plus 2 cancel. And here they both cancel. So let's see what we end up with. Well, we end up with 1 times x plus 2 minus 1 times x minus 2 equals, and both of those cancel, so that's going to be 4. Alright, so now let's just clear the parentheses and solve. So we get x plus 2 minus x, and negative 1 times negative 2 is 2, equals 4. And you can see the x's go out, and we end up with 4 equals 4. Alright, so the variables went out. We end up with 4 equals 4. So what we do is we look at this. 4 equals 4. Is that a true statement? Yes, it's a true statement. So that means we have an infinite number of solutions. Now, you might be thinking about when you were solving linear equations, you might say, well, it's all real numbers. Well, no, it's not. Actually, the answer is what? The set of all x such that, so that means it's all the real numbers x, such that x does not equal negative 2 and x does not equal positive 2. Okay, and yeah, you know, you could write it like this also. Okay, so this is one way to write it. How does your teacher want you to write it? I don't know. I've seen books do this, and this is, you know, this is acceptable. Another way you can write it, I guess if you want to write it as an interval, like interval notation, the easy, I guess an easy way to do it, let's look at this. If you have negative 2 and positive 2, say like a number line, because that's the two numbers that can't be. And if we graph this, or let's do this, if you look at this, your answer is the entire number line except negative 2 and positive 2, which there would be holes in the graph there. So your solution, if you wanted to write it in interval notation, you would write it as what? Negative infinity to negative 2, or union, everything in between here, negative 2 to 2, or union, everything from 2 to infinity. And what this does is that this right here, with the, remember the parentheses means the number's not included. So what it does is this is all the real numbers, but it's skipping over negative 2 and positive 2. So there's an answer, and there, how your teacher wants it, I don't know. You can ask them. So, but that's two ways to write it. And you could write it out in words too if you wanted to, I guess. But hope this video helped. Check out the other videos. Give me a like, share, and subscribe, and thanks for watching.